I'd like to introduce our two speakers for this session, and it's the topic is ending a boiled water advisory and how quickly can the water flow. It's presented by John Burgess. Did I pronounce that correctly? John has over 10 years of combined experience in academia and consulting as a member of EGBC. He has a wide range of academic consulting and field expertise. His passion has been working with and supporting Indigenous communities. He's been involved in implementing, innovating project delivery models and addressing several long-standing boiled water advisory projects where he collaborated collectively with the community and stakeholders to lift the advisories. And the second presenter is Julia Kerr. Julia is a civil engineer in training at Urban Systems. She has a range of experience with First Nations water and wastewater system projects and is passionate about harnessing alternative project delivery methods to implement the optimal solutions for the client and water operators. So with that, I'll turn it over to John and Julia.
Thank you so much for the introduction, and good morning, everyone. We'll just wait a few more minutes as people are settling in. Well, thank you so much for the invitation on this presentation. This is a collaboration project with Whispering Pines, Clinton Indian Band, and Urban System, where we recently completed a project where we lifted a boil water advisory for one of the smaller communities. So we would like to just present you our approach and some of our results of the project. So first, we would like to acknowledge that as visitors, we are situated on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh. We're just visitors here, and it's important to always remember that. We also like to thank all the team members involved in this project, starting with the Whispering Pine Clinton Indian Band community, Chief and Council, administration, the water operator, Indigenous Services Canada for the funding opportunity, First Nations Health Authority Environmental Health Officer for his expertise and contribution, the circuit rider for all his time and insight, and the contractor who actually implemented the upgrades and improvements. So with that, we'll just get started. Whispering Pines Clinton Indian Band is it's a community located 35 kilometers north of Kamloops. It's in a semi-rural area, so some services not close to a service center. There are about 35 homes in total, and about a couple community buildings, administration, and daycare. So the community is actually serviced by two main community water systems. The main community water system that services the subdivision and an administration building, and as well as the small water system, which is considered the band office water system, and that services 4 or 5 homes and 2 administration buildings. So the focus of the project was to address the improvements on the band office water system, because they'd been on a do not consume boil water advisory for a number of years. So the main water system, the main water community system consists of 2 well waters providing raw water to a water treatment plant for iron and manganese removal. Chlorine is primarily used for primary and secondary disinfection, as well as pre-oxidation for the iron and manganese removal through filters similar to the Philox. Partially buried concrete reservoirs provide storage and gravity distribution to about 28 homes. The band office water system provides water from an individual well with no treatment and disinfection or a reservoir to about 5 homes, as well as a band office as a daycare. So given that it's an individual, it's a small, shallow well, there was high nitrate concentration, which placed the system on a do not consume advisory for a number of years. Given that it's an on-demand system, there's no opportunity for expansion, given no reservoir, and as well as no fire protection. So the way we came about this project is that the community has been wanting improvement on the system for a number of times. So we kind of looked at a different approach on how to implement the changes. So we're engineers, so obviously we start with a feasibility review because we like to do assessments and understand what's going on. So we looked at the two main improvement assessments option. One was a localized solution, build a new water treatment plant for the system. And then the other was extend the water line from the main community water system to all the way to the system. A variety of water line dimensions were assessed. A 50 mil for just domestic versus a 150 for both domestic and fire flow. So the 150 was determined as a preferred option, given the opportunity to provide both potable water as well as fire improvement, fire protection in the future, as well as community growth in the future. So with that, it was our assessment that basically instead of building another water treatment plant specific for that community and have additional O&M costs, more headaches for the operator and handling several systems now, if we're able to extend the water line, you would just be a continuation of the same. This also provided, the community was quite excited about that because it provided expansion opportunities in the future with the new water line. Fire protection was being considered given the size of the water line, as well as then newer connections, more connections, provide an opportunity for having a rationale to increase the water storage for the reservoir, for the existing water reservoir as well. So we looked at three main option alignments from the community water system. Three options: Route 1, the orange, where it goes through a future subdivision and then crosses over the highway and then down to the band office area. Route 2 east down towards the North Thompson River and then over, and as well as Route 3, which basically did straight down from the reservoir, did the crossing, and then over. So given these three options for the alignments, it was Route 2 was the preferred option because it avoided some geotechnical hazards because there's a solid pit through one of the other alignments. It avoided any potential future relocations given where the new subdivision was going to go, as that was still in the design phase, as well as it minimized disturbance to the community roads, given that it was less developed down east. So following the feasibility study, we wanted to kind of jump right into implementation as opposed to like completing a design, writing the report, issuing drawings, then doing the traditional design bid tender. So with that, I'll pass it over to Julia, who will speak about our project approach and how we kind of moved on from this.
Thanks, John. So as John said, basically we wanted to use an alternate delivery approach as opposed to the traditional design bid build. And this was for two reasons, because the community, first of all, had been on a do not consume order or advisory for over 7 years at this point. So those 5 homes in the band office and the daycare. And also Indigenous Services Canada had a surplus in funding and they needed it to be used quickly, essentially. And since this project was technically already set up and ready to go, it was a perfect opportunity for that. So the approach we went with is a negotiated RFP. A negotiated RFP is kind of halfway between design bid build, so going to tender, and an IPD project, which is integrated project delivery, if anyone's heard of that. So it's a collaborative approach. You actually bring on a contractor before you finish the design. So when we issued the RFP, the design was not complete. It was only a concept, and we'd only done the feasibility study. And then you bring on the contractor as part of the team. You complete the design with them and with the owner and with the other stakeholders of the project. And then it's actually a lower risk project for the contractor and for the project in general, because the contractor's initial bid is actually not set in stone. So as we go through the design, the scope may change, and then you negotiate that bid price at the end before you sign the final contract. So in this project, this was our kind of project team. So the owner is Whispering Pines Clinton Indian Band. We also had Indigenous Services Canada involved, obviously, in the funding, and they also provided some technical support, so they were part of our design process. The contractor was also part of the design process. We also had FNHA involved as well. They kind of advised on some of the water quality testing requirements, especially for such a long water main. And then finally, we as Urban Systems, we were the consultant, and we also did the environmental work, and then we hired a geotechnical consultant to help out as well. So just to go a bit deeper into the negotiated RFP process, so basically we put together a request for proposal based on a conceptual design. So we developed a schedule of quantities that was not set in stone. We included that in the request for proposal and then sent it out to 3 contractors that the community was either familiar with or that we knew had a good reputation and that the community liked working with. We then vetted the contractors not just based on price, but it was actually based on a set of qualifications. So they were vetted on experience, their proposed schedule, value-added solutions they were asked to provide as well. So in this case, the decision between using HDPE and PVC was not very clear, so we wanted their input on that as well. And then we reviewed the submissions based on a set criteria that we had laid out in the RFP before, and then ultimately the community decided which contractor they wanted to go with. After we selected a contractor, we needed some background information, but because of the streamlined design and the streamlined process, we decided to forego field investigations. And we felt that we could do this because we strategically selected sub-consultants who had a lot of previous knowledge in the area. So we had worked with Whispering Pines a lot previously, and then also our geotechnical consultant had done a lot of test pit reviews and field reviews before then. So we only did desktop reviews before completing the design, essentially. So that was geotechnical and environmental reviews. And then the actual collaborative design was, the method was basically 3 virtual design workshops. So in those workshops were all the stakeholders that I mentioned before, and basically everyone attended each one. So Indigenous Services Canada did, FNHA attended, the owner attended, so their chief and council, as well as some of their staff. And we basically coordinated and discussed the project scope. So that included like the alignment, the materials we were going to use, which community members and which homes were going to be connected. We also all came to the table with improvements that we thought could be included in the design, and then we compared those improvements using a method that I'll discuss on the next slide. We also discussed cost implications and risk factors. It was really useful having the contractor involved, especially with, as we all know, supply chain issues are a huge deal right now. So it was really useful having the contractor who had real-time data on the availability of products, the pricing of products. So that also helped with schedule implications as well. And then the design workshops were actually surprisingly successful and surprisingly impactful on the final design. So it ended up changing the preferred alignment that we had come up with in the feasibility study, and it also changed the pipe diameter and material, which I think just goes to show getting everyone's input can make a huge difference. So these were actually the new preferred alignments. One of the big improvements that came out of the design workshops was that we discovered as a group that we do not have to cross West Side Road, which is kind of that highway at the top there, in order to connect to the existing community system. So that was a big cost-saving measure. So instead of crossing West Side Road, we could just go right through, cross that existing water line, and then connect by the community hall there on the right. So that's where Route 2A and Route 3A came, because they were just kind of an alteration to the original design. And then Route 2 was the same as the original, so it still crossed West Side Road. But it turns out the two kind of top solutions were Route 3A and Route 2A. So that's what we compared. And one of the methods we used to actually select the final design was a choose by advantage method. So essentially you set up these tables and you come up with the most important criteria to the community and also to the engineers and the contractors involved. So those were things like timeline, pricing, market availability, operations and maintenance complexity, ease of construction, things like that, so listed there. Then, as a group, you weigh each criteria based on what your priorities are and what the owner's priorities are, and then you score them as a group as well. So this is actually an example of one of the tables that we used. So this was for alignment 3A. So we scored alignment 3A and alignment 2A, and we also compared HDPE and PVC and 6-inch and 8-inch. And it came out that HDPE is more favorable for kind of the transmission line because it's more durable and it's more, robust in uncertain geotechnical considerations, which we had to consider because we didn't do field investigations, as you may remember. And then PVC was actually found to be better because the community, the water operator, as well as the contractor were all more familiar with PVC because it's been used for longer. So we were all thinking it would probably be preferable to use for areas that had a higher number of existing service connections as well as potential future service connections. And then we had to have 8-inch in there for higher fire protection as well. I do want to mention that choose by advantage tables are not actually a final decision maker. They're just a tool to help you make a decision, especially when things are kind of unclear and there's not a set answer. It's just a helpful aid, but the decision is basically the communities as well as, the final decision is the communities really. And then finally, for the smaller design components, we worked a lot with the contractor, a lot of it, and the circuit rider as well, and operators. And a lot of that was based on their previous knowledge, like what they like to work with, what they've had good experience with. This was in terms of like hydrants and valves and air release valves and things like that. And then also based on the contractor's knowledge of availability and market pricing and things like that. So that helped decide the more specific items. And then finally, another big step we had to do before finalizing design was CP holder agreements, so certificate of possession. And because the water main alignment, all the routes actually had to go through some CP holder land. So we had to come up with some right-of-way agreements so that the operators wouldn't run into problems later on when they had to maintain the water line that was going through that land. So that was definitely a long process, but it ended up being helpful in keeping all the community members informed. This was from our final design workshop. We did not use this as the design drawings because it looks like I made it, because I did. But yeah, this was basically came out of our final design workshop as like the high level figure of what the design was. So as you can see, the dark blue is 150 millimeter PVC, which we use for areas with a high concentration of service connections. The transmission main, we decided to go with an 8-inch HDPE for the durability as well as a higher flow rate that can go through there. And then finally at the bottom there, we went with a 100 millimeter PVC because it's all CP holder land, so there aren't expected to be any future connections. And then, yeah, I kind of identified where we were gonna put some of the details. So how do we engage the community? Through the nature of this project implementation, you end up engaging the community a lot through the process kind of naturally. So in the design workshops, like I said, we had the chief and council there at every workshop. They were kind of our main communication and connection to the community for that stage of the project. But then after that, we presented as well at one of the community, it was like a community engagement workshop. It was a community meeting, basically. We presented there, a lot of members attended, and we answered their questions. We also distributed pamphlets before construction was going to start, and then also when specific homes were going to be impacted. So all the homes needed pressure reducing valves because of the difference in elevation. So before we were going to enter people's homes, we distributed pamphlets as well. And then we ended up having a lot of consultation with community members on site, just by the nature of the project as well. We were on site a lot, and a lot of the project was going right through people's properties and things like that. So there were, as a result of that, there were some last minute changes, which ended up being fine. So we had to move a couple yard hydrants. We kept one more well connected than we thought we were going to. But it was through having that open communication between the contractor, us, and the owner that we can make that happen. So the construction timeline and actually the timeline of the project, just to give you some context, we started the RFP. So we, I guess, wrote the RFP in late December, and then it was closed around January 20th. And then we did the design we completed the design by the mid-March, around there, mobilized on April 11th, and then total performance was August 9th, so pretty recently. But the whole project was around 7 months, starting from the end of feasibility to end of construction, which was it was actually quite impressive. It was a really quick timeline, and the collaboration helped a lot with that. Some of the construction challenges we had as a result of the streamlined design included unexpected topography. So we did not get a topographical survey done beforehand, and that was because we had LiDAR in the area, but the LiDAR was around 10 meters apart. So there were a couple hills and dips that we did not get, but the contractor just field fitted the alignment and it ended up working out, so that was good, and then they just tracked their changes. We had an existing water main or water line crossing, as well as a TMX pipeline crossing, because the pipeline goes right through the community. So we had to get a TMX permit approved for that, and then also the TMX representatives are there when you're hydrovacing around the pipeline and excavating around there. We had the CP holder and easement agreements, as I touched on before. We also ran into some unexpected existing infrastructure, which happens. So there was a 12-inch decommissioned pipeline that we had to go around. There's also a septic field. So we excavated around the septic field and then followed the drinking water guidelines to go through there. And then there was a little community garden shed, which we just removed off the alignment and then replaced once we put the pipe in. And then one of the other tough parts was actually just locating services. Like, a lot of the work in the homes took almost the most time, I would say. These are just some photos from construction. So top left is the TMX pipeline after it was excavated and hydrovaced. Bottom left is the HDPE being installed, which is kind of a cool thing to see. The fusing is also pretty interesting to watch as well. And then on the right here is that septic field that we had to go through. And then these are some of the photos just from after construction is completed. You can't see much with a water main, but top left is the hydrant. Bottom left is just part of the alignment after it was already filled over. And then on the right there is the water operator and the contractor just checking that all the valves and air release valves are working. And then finally, to complete the project, we did the bug tests and pressure tests that once they were approved by FNHA, recommended the removal of the do not consume order, which was really exciting. So people now have water flowing into their homes. They used to have to truck it in. And then The final timeline of the whole design, as I mentioned before, starting from, I guess, December when we wrote the request for proposal up until construction was about 7 or 8 months. So pretty quick. And then this photo here is just them tying into the existing water main. This is just the overview figure from our record drawings. One of the other changes that happened during construction is on the bottom left there. One of the community members let us know that the CP holder ownership had changed, basically recently, and that they were probably not going to sign the right-of-way agreement. So we had to do a quick change about 2 weeks before we were getting to that area. And then instead of going through the CP holder land, we went down across Black Bear Lane and then served those homes. So reflections and lessons learned. I guess collaboration brings out the best in us. I found this process to be really useful for forming those relationships with the owner and the contractor before you get to the really stressful part of a project, which is often construction. Because we did the design together, when changes did happen in the field, I thought the communication was a lot more seamless, and also there's more understanding between each party as well. So it made the construction process a lot more enjoyable, I found. Community involvement as early on as possible we found was really useful. Because like I said, our design from feasibility to what we came up with at the end of those design workshops was actually quite different. So that was great to know. And then keeping the water operator involved throughout the process was really important too, for getting input on those smaller design details as well. And we are really just visitors, and the community knows their needs best. The risk management approach of the collaborative method actually ended up being pretty successful. We only had 3 change orders, and they were all small in magnitude compared to the project budget. So that was pretty awesome. And so I would say in general, it does reduce the risk of change orders because you predict and try to anticipate those risks before going to construction. And you get the contractor's input on constructability, which often is overlooked sometimes by engineers. And then finally, it takes a community to implement change. Like, this process has been going on so much longer than before John and I got involved, and there were so many community champions trying to make this happen. And we were honestly just lucky enough to be working on it when it was able to be implemented. And we were really grateful for that. So yeah, thank you all for listening. Are there any questions? Yes.
Sounds like you had more collaboration with the contractor and the operator than you normally do, which helped you out. Is that something that you would be doing in the future, or was it specific to just this project?
Okay, sure, yeah. I believe it was, well, I would say we hope to continue that in the future. In terms of funding for these projects, I think it's there is like a certain type of project, especially with Indigenous Services Canada, that they would want to fund for this. Also, alternative project deliveries, there are many different kinds, and a lot of them have that kind of collaboration aspect as well. So it really depends on the project. This one worked really well because it was a water main, so it was kind of a simple design. We could streamline it. But on really complex projects, often people go with maybe integrated project delivery, which is more stringent, I would say, but also has that collaborative aspect to it as well. But in terms of, so I would say with the contractor, depends. With the water operator, I would say, yeah, it would definitely continue on most projects. But
and to further mention on that, IPD provides the reward scenario as well for the parties involved, whereas the negotiated RFP just basically there isn't a reward system. The reward is making it the project a success.
Can you hear me now? I have 2 questions. The first was there any community resistance to the project? that you encountered?
Good question. I think what we heard the resistance was through the CP holders and where we were suggesting the alignment to be placed, basically. So it was more of maybe consideration than a resistance.
Yeah, and I would say in the community there was also some distrust of the water system just based on the history. So I think there was some work that needed to be done to get around that as well, and extra communication that was needed on that. But in general, when we would ask staff and community members, it was supportive.
I guess I have 3 questions. Is it an unchlorinated system, or is it chlorinated?
It's a chlorinated, primary and secondary via chlorination.
And then finally, what kind of connection system did you use to join the HDPE and the PVC?
It was a gate valve, and then we had a reducer on one of them as well.
Yeah, given the size differences between the pipes.
The mechanical restraint to join the HDPE to the HDPE, the HDPE is notoriously malleable. So I'm just wondering if there was a special connection that you had to do to make that happen.
So it was through the gate valve, but so the connection was coming, the HDP to the gate valve and then over to the PVC from the other side.
So was the HDPE welded to the gate valve then?
Yes.
Okay, thanks.
Yeah, and then there was a mechanical restraint on the PVC side.
Online?
Yeah, I think I saw some on there.
There's actually one from online, but I can address it. The question, the question basically says, is this presentation going to be available after the event? These presenters very generously have said authorization yes to record, so we will have this presentation afterwards. Some presenters at EOCP 2022 are presenting on proprietary information that cannot be recorded or distributed after, but this is one of the presentations that will be available after the event, because you guys said yes on my form.
How the well close to the band office became under Boiling Water Advisory in the first place? Was it an old well, or was it built for one dwelling and then it became, it connected to some other dwellings, or what were the circumstances in which?
Yeah, it was exactly that it was first put together for maybe either the band office or one home, and then more connections were added to it, and over time there was nitrate infiltration as well, so there were very high levels of nitrate concentrations on it, and hence. Sorry, there was one down.
How did you address storm and flood in case of vulnerabilities against the system that you put in?
It's a buried system, so do you mean through construction or?
Yeah, through construction of.
Yeah, we just got lucky with the season that it was, yeah, I think we didn't see a lot of precipitation at all. But it would have been a construction management issue by the contractor, how to deal with that. I think luckily, given the time where they were doing the excavation, it was pretty dry season, so.
And that was actually, that was also one of the factors in why we chose the route that went along West Side Road rather than the route that went along the North Thompson. And actually, while we were there during construction, Whispering Pines is in that 200-year floodplain, and Urban is also working with them on dike improvements and things like that. So they already have a protective dike along the river, but it is definitely a vulnerable area. So that's why we chose to go up along West Side Road.
With that, we have a warm round of applause for our presenters.
Thank you, everyone.
Thank you so much.